So we'll give it a couple of minutes for people to come in and then we'll get started. Hi, Kamil.
Hey.
Let's say like 2 minutes. We're embracing the awkward style. Come. Okay. I think you can get started. All right. So welcome to Shiny Gathering. We are so excited. We're so excited that you could join us today. I'm Gigi, the internal journalist at Appsilon, and today we'll be learning from Kamil, who is. Okay, I'm hearing a bit of echo on my end. Can you hear it too, Kamil?
Yes.
Okay. Not awkward at all. Is it that bad?
Like there is some issue with your audio, I guess, but mostly understandable. So I guess just continue.
Yeah. All right. So let's take too much of your time. Kamil will be taking us to developing in Rhino, and please feel free to ask your questions, leaving them in the chat. I'll give it towards the end of the session. All right. So I'm going to hand you over to Kamil now, and let's get started.
All right. Thank you, Gigi, for introduction. Let's start by sharing my screen. All right. So welcome to Shiny Gathering 11. Thanks for joining. Today I will be talking about new developments in Rhino over the past year. So to clarify what I have in mind for today's meeting, I see it in three main parts. First of all, I'll give you a brief introduction to Rhino. For those of you who are not familiar with it or just used it a little bit, I will briefly tell you about the history, about the philosophy behind it, and overview the features it provides, but I won't be going into too much detail here. The main portion of this meeting will be a presentation of the new features added over the past year, to be exact, spanning versions 1.4 to 1.7, which was released just last Thursday, so very recently. And while I will do this with some leaf coding style presentation. Lastly, we'll have some time to chat, whether you have questions regarding the presentation, Rhino in general, or anything else actually regarding Shiny. This is a Shiny gathering after all. It doesn't have to be necessarily all about Rhino. All right, so let's get started with a short introduction to Rhino. So what is Rhino? We say that it's a framework for enterprise Shiny applications, but what does that mean? Let me start with a little bit of history. So we started using Shiny, one reason being that it was extremely easy and fast for us to create applications in Shiny, which were interactive and impressive for the client. Really, all you need is just a single file, and you can create an application which can be really impressive. And the speed of development is something that we really appreciate about Shiny. However, many of the projects that we had would not end up as a simple application, but continue to be developed over periods of months in teams of multiple people. And when that happened, it was not possible to keep everything in a single file, of course. We had to invent some more thoughtful structure for the application. We had to use tools which would ensure the quality of our work and that development wouldn't stall after a while due to technical debt and just like unthoughtful design. So we wanted to have some tool which would provide us with a structure and tools that would help us to develop quality applications, and we did not want to reinvent that each time we were starting a new project. So out of this need, Rhino was born. Actually, it had a couple of predecessor projects, but I won't be going into those details. So Rhino. What does it mean? What does it give you from a high-level perspective? So first of all, the project structure. Once you initialize a Rhino project, you will get a couple of files and directories. So you'll have places to keep your sources, static files, configuration, and anything else that you might need during development. You also get a complete development toolbox. So things like linters, tools to build your JavaScript and Sass, which we use in Rhino, and tools for configuration, basically everything you might need during developing an application, which is meant to live long-term and to be developed by multiple people. Lastly, Rhino is there to nudge you towards some good practices. In many cases, you'll be able to do exactly what you want if you're not satisfied with the structure or setup that Rhino initially provides you. But the goal is to provide such an initial setup that by default, you'll be using the best practices, at least as we see them based on our experience in creating applications for our clients. So this is what Rhino is from an abstract perspective. Now, technically, it's simply an R package, which means you can install it just like any other R package. So by calling the install packages function, you'll simply grab the latest available version from Chrome, which is 1.7 right now. Then once you have Rhino, you can start a new Rhino application by two possible ways. Either if you're using RStudio, you can use the new project wizard, which is what I'm going to do in this presentation. Or if you are using some other IDE, or if you work directly in R console, all the functionalities of Rhino are also available as package functions. In this case, you can call Rhino init. So once you do that, what do you get? You get this complete structure presented here. Don't get overwhelmed with it. We won't be going into all the details here. I'll just overview the sections that we see here. So you can see 5 colored boxes. These are groups of files with similar purpose. Let's start with config. So rhino.yaml is a file which contains Rhino-specific configuration. Config.yaml is a file which you can use for your own configuration if you are running your application in multiple environments, right? Like development environment, production environment. This is where such configuration can go. Our profile is for settings which are sourced each time you launch a new R session. Moving on to sources. This is the main portion of your application. And at the top here, we have app.r, which actually contains just an entry point to your application. Typically, you won't be editing this file at all. Instead, all sources of your application will live in the app directory. And starting here, first of all, we have main.r, which is the top-level UI and server of your application. This is where you put your top-level UI and server, things that will be visible when launching the application. Then we have logic and view. These are 2 directories which are also meant for your R sources. And this is where this nudging toward best practices comes into play. You are free to use a different structure for R sources of your application, but this is a suggestion that we think works quite well. The idea here is to split the logic, which is independent from Shiny functionality and especially reactivity, from view, which are definitions of Shiny modules which rely on reactivity and other Shiny functionalities to build your application. The reason being that reactivity makes it really easy to build an interactive application, but at the same time, it makes it difficult to test the code. By splitting the pieces which do not need reactivity, like some computations, generating diagrams, accessing database. These kind of things can be tested more easily. Moving on, we have static for static files, things like images and any other files that need to be available on the server. We have JS for JavaScript sources, styles for Sass sources. Sass is an extension language for CSS. So you can see that out of the box, you get directories not only for working with R sources, but also with JavaScript and Sass. The reason being, in most of our projects, we find that sooner or later, we cannot find a package, R package, which meets all our needs. And we use these technologies, which are the underlying technologies of modern web anyway, and also the underlying technologies of Shiny. We use them directly, oftentimes, to add some functionality which wouldn't be possible with just an R package. So this is the main part. Let's move to the 3 boxes on the right. We have dependencies. Rhino uses Rn to provide you with an isolated and reproducible environment, meaning that when you install packages, they are installed just for your project, not for your whole system. And it's being very explicit about specifying what dependencies your project uses. So you can see that we not only have this rn.log file, but we also have dependencies.r, which is a place where you explicitly list the packages which you directly use in your code. We'll see that in action during leaf coding. Then we have a directory for tests. You might be familiar with test.dat, which we use for creating unit tests, which typically test single functions, sometimes a couple of functions. But we also have Cypress, which is a JavaScript technology, which allows us to create end-to-end tests. You can also use Shiny Test2 for that purpose in Rhino. However, Shiny Test2 has some limitations when it comes to testing components with custom interactions. For example, Shiny Test2 will set inputs directly instead of interacting with the input in the browser. And if we want to test logic of that interaction, we would just skip that with Shiny Test2. Cypress is a widely used technology for creating end-to-end tests, which allows us to test even in this kind of scenarios. Lastly, we have the box with tools, a couple of miscellaneous things here. .github is a directory with a workflow which will automatically run all the tests and linters in your project whenever you push to GitHub repository, which is the main portal which we use for our repositories most of the time. .lint_r is our linter configuration. Lastly, the R project file enables you to open your project in RStudio. So this is an overview of the structure which you get after initialization of a Rhino project. And to an extent, I also overviewed the tools that you get together with Rhino. But I won't be going into more detail here because I'd like to focus on the newest features added over the past year. If you'd like to learn more about these things, the best place to go is our documentation page. The link is here on the screen. We have tutorials, which is the best place to start if you've never used Rhino before. Explanations, which are like high-level overviews of topics and design decisions behind Rhino. How-to guides for detailed step-by-step instructions, how to do things, typical things that you want to do in Rhino. And of course, a reference with information on each function available in the R package. If you cannot find answer to your question or face an issue that you cannot resolve, you're welcome to post a question on our discussion boards on GitHub. If you just search GitHub Appsilon Rhino discussions, you'll surely find it. Lastly, before going into the leaf coding, I want to tell you that Rhino is actually part of something bigger that we call Rhinovers. So the short story is that as we work on the projects for our clients, we sometimes face situations when there is no R package yet, which does the thing that we need. And on those occasions, we created packages, and with time, the family of those packages grew. At some point, we figured that we should be striving more to make this coherent, so these packages work well together, and that they work well with, in particular, with Rhino as a foundation. And this is what Rhinoverse is about, to provide a family of packages which work well together, and especially with Rhino, and to address the needs of modern web development. Be sure to check out the other members of the family on rhinoverse.dev. All right. So this is it for short introduction, and now it's time for the presentation of new features with some Leaf coding style presentation. I won't be doing too much coding, actually. The point is to showcase the features, but not on animated GIFs, but actually Leaf how they work. So I have our studio open here. The first thing I'm going to do is use this button to create a new project. Let's start it in a new directory. Scroll down to find application using Rhino, and I will call this one Gathering. Create project and give our studio a couple of minutes to load all the dependencies. We start the R session, and we are presented with this project structure, which I described on the previous slide. So first of all, I'd like to show you a feature introduced in the latest version 1.7, which is automatic reloading. This will be useful during the rest of the presentation. So to enable automatic reloading, what I need to do is to set the Shiny auto reload option to true in my current R session. Now I can launch the application and see this in action. So to launch the application, I will open app.r and click Run App button. The application launches here. The initial template just gives you this link to check out Rhino docs, which is nicely centered, and that's it. All right, what I'd like to show you is how I can edit files of my application and see the changes immediately reflected in the running application. So to edit this message, obviously I won't be editing this file because this is just an entry point and the comment tells us not to edit it. As I mentioned, the actual... Yes?
Sorry for interrupting you. We can't see your screen.
You cannot see my screen.
Yeah.
I will try to share again.
All right.
How about now?
Yes, thank you.
Can you see the slides when I change them?
Yes.
Oh, all right, awesome. Maybe I shared just the slides instead of whole screen. I'm sorry about that. Anyway, back to the presentation. Automatic reloading. So far, I have only created a new project, and I enabled automatic reloading by setting Shiny auto reload to true. This is this line of code here in my current R session. Then I run the application, and this is what you see. So I'd like now to show you how I can edit the sources of my application and how this will be automatically and immediately reflected here in the running app. So to do that, I will go to the app directory, and this is where actually the whole application lives. And I will edit this main.r file, which is the definition of the top-level UI and server. So let me just change something in this message like this. And once I save this file, my application immediately reloads and the message changes. If I make some mistake here, save it. First of all, our studio will warn me that there is some problem. I can also see in the terminal that something did not work. Rhino couldn't reload the main module. But as soon as I fix it and save the file again, my application will reload and I can see the results here. So this is something that I will continue using throughout the presentation. It will be very helpful throughout your development, I hope so as well. So for the purposes of this presentation, I'm going to do some refactoring. And here I want to briefly discuss some unusual aspects of this definition of UI and server. You can clearly see that it's a Shiny module, a function taking ID, and we are using this module server function here. And this is unusual from perspective of building Shiny applications because even your top level UI and server form a Shiny module. And the reason we do that is because it makes your whole application consistent, and when you want to refactor it, it is very simple. For example, typically when you start a new project, you will start coding right here in the main module. But soon it will grow and you'll want to split it into smaller modules in multiple files so that it is easier to collaborate on them and it's better organized. And let's try to do that in this example. I'll create a new module and I will move the UI and server that we have here into that new module. And at this point, I would like to show you another feature introduced to Rhino in version 1.5, which are RStudio add-ins. So let's take a look at this add-ins button here. I will search for Rhino to see all the add-ins available for Rhino. And I won't be showing you all of them. I will start with Rhino module and show you a couple more during this presentation. So let's create a new Rhino module. I get a window which by default suggests me to create a file in this app view directory, which is where new modules should go. I will call this one docs because this module simply displays a link to the docs, so it makes sense. Once I hit save, a new file is created and opened. This file lives in the view directory, and I can do my refactor. So what I'm going to do, I will move the UI code to here, and I will move the server part as well. What's this? Here. And you can see that it's really quite simple because my UI and server were already defined as a Shiny module. So taking into account this namespacing function, for example. So I can really just move code. Of course, I also need to move the box imports. And I'll just swap these ones back to this place. So I can save this file. So I have now a module which defines this nice message. And to use it in my main module, what I need to do is to first of all import the docs module. This is done by adding an import statement with a full path to the module starting with app. So I say app view docs. Now I need to put the UI of my module somewhere in my UI of the main module. I do it like this. Here we need to remember to wrap the ID in the namespacing function. And lastly, we'll need to call the module of the docs server in our server function. Here we do not apply any namespacing function. This is done automatically by Shiny. This is just something that you need to remember about Shiny modules. All right, so once we have this, we should be able to save the application and hopefully nothing changed. This was refactoring, so the goal was for the application to work exactly as it did before, but with changes to the structure of the code. So let's try to do something more. Let's take a look at this module now. There is still some improvement that I could see here. We have this inline style here. So our div contains a style tag, which has some styling information. This is good enough for a short example or a demo, but this is not how we'd like to do things in general, because it's hard to say just by looking here what this code does. And what it does is basically centers this text. So it would be much more understandable if we created a class called center and applied it here. So what I'm going to do, I will cut this code and replace this with a class called center. I will save the file. And now we see that our text is no longer centered because we have not yet defined this class. Now, to define this class, I will go to app styles and open this main SCSS. And this is the place where I can define my CSS. Actually, this is not plain CSS. As I mentioned before, it is Sass, which is an extension language to CSS, but it is compatible with CSS. So if you are not comfortable with learning something more, you can just use plain CSS here. And once you want to use some more powerful features, you are free to use them at any time here. And I won't be going to the details of what features are available because this is not a tutorial on using Sass. So let's just stick to plain CSS. I will define a class called center, paste my code, which I cut from the module, add some new lines for clarity, save the file. All right, it's still not done. Our text is still not centered because this file is not loaded by Rhino directly. Instead, it builds it into a minified CSS file, which is optimized and ready to be used by any browser. And to do this building process, we'll use another add-in, which is called build Sass. I will be asked if I'd like to keep the process running and rebuilding my CSS whenever I introduce changes. I will say yes. In a very similar manner to Shiny auto reload, this will help me to iterate quickly and see the changes immediately when I apply them. We can see that, first of all, it's taking a while to initialize Node.js. Node.js is the underlying technology which we use to provide you with these tools for working with JavaScript, Sass, and also for working with Cypress end-to-end tests. But this happens only once per project, and next time it will be instantaneous. You might have noticed that the compilation completed, my application reloaded automatically, and my text is centered once again. If I wanted to play with this more, say, set some fancy background, I can just hit save, and my application will immediately reload and show the red background. But that's a bit hard on the eyes, so let's go back. All right. So our module looks pretty nice now. So I'd like now to discuss some other aspects of Rhino, which we already touched a little bit. So you can see that the code of a Rhino application looks somewhat different from a typical R script or a Shiny application. Somewhere in a Shiny or application or just plain R script, you'd expect to see several library calls which specify all the packages that you are using. And those will just attach the complete packages along with all the names that are available in those packages. So they are available throughout your whole project. And this is extremely convenient when working interactively or we're creating a very simple project. But as it grows, it becomes quite unwieldy. The problem being, if you have many libraries, they will import a ton of names into your namespace. You'll probably encounter some clashes, so you won't be sure where a filter function comes from exactly. It might even start clashing with the functions that you define yourself. And also, it becomes very difficult to understand, even if you split your application into multiple files. If you look at a single file, it becomes difficult to understand where the functions it uses come from, what packages this file uses exactly. So it becomes difficult to reuse code, to refactor it. Basically, the lack of explicitness, while very convenient at first, becomes a burden as your application grows. So with Rhino, we wanted to make this kind of things explicit, and we chose to use box for that. And this package allows you to use these box use statements, which basically provide an import system similar to other modern languages like JavaScript, Python, Java, sorry. So with this box use statement, I'm able to explicitly say which packages I'm using, in this case Shiny, and what functions from that package I need, and also what other scripts I'm loading. In this case, I'm just loading the whole module, and then using the functions from it using the $sign. And we really like using box this way, but as we kept working, we saw that these box use statements can bring problems of their own. They need maintenance. You need to add things here as you build your script. and you need to keep it organized in some way so it remains readable. And this is why in the latest Rhino, we have introduced another feature, which are linters for box import statements. Let me show you this in action. I will use another add-in here. This time I will lint my R code. And you will see that there are two issues with my code here. Both are regarding the main.r file. One tells me to split the box use statement into two statements. So one contains just the packages and the other only the modules in my application. So let's do just that. And the motivation here is that this makes it easier to see at a glance what are the dependencies of each file and what are the files it uses and what is a package and what is a module inside your application. And the second warning here tells me to add a trailing comma. This is a small thing, but it simplifies adding new lines, reordering lines, and basically this box statement supports it, and we found it to be a good practice. There are two more linters, which I'm not showing you here. The idea being that once you start linting your code with these somewhat strict rules from the beginning, you will be able to keep your box import statements really tidy and readable in the long run. So after saving this file, I can rerun the linter, and hopefully this time no style errors were found. All right, let's move to the last bit of this presentation, and let's do something more exciting. For that, I will need a package. I mentioned that Rhino tries to be explicit about the dependencies of your project, and we have this dependencies.r file, which has a list of all the packages which you are directly using in your project. And I'd like to add a package called Shiny React here. And a brief historic note, in the past, you'd need to do this in 3 steps. You'd need to add a line to this file, then you'd need to install the package using renv, and lastly, you'd need to update the log file also using renv. And in the latest version of Rhino, actually first in version 1.4 and then with some updates in version 1.6, we introduced some improvements so that managing dependencies in your project is more streamlined. You don't have to perform multiple steps, that you have just a single function which can do all these things for you in one step. Let's see this in action. I'm going to stop my application so I have the access to the console again. The two functions for dependency management are called package install and package remove. Package remove obviously will remove a dependency from your project. Package install can be used to both update a dependency or add a new dependency to your project. And the latest improvement added in version 1.6 is that you can not only install from cron, but also from local sources, Bioconductor, GitHub, and you can also install specific versions. In this case, I will just want Shiny React with the default latest version from cron. If I wanted something else, like a specific version, I could do it with this syntax. Of course, you can take a look at the documentation of this function to learn about the available syntax for other purposes. But I want the latest version. Let's do it. First, I'm asked if I want to install this package. It could be the case that it has additional dependencies, and then I would see a list of all the packages that need to be installed. In this case, it's just Shiny React. Let's get it. And then I'm asked if I want to update my log file. Let's say yes as well. And we're done. As you can see, my dependencies.r was updated. I have a new line with Shiny React here. Also, my log file was updated. I won't be showing that because it's a long one. It's not typically meant to be read by humans. This is a generated file. Anyway, this is all I had to do to add a dependency to my project. So now we have Shiny React, and what can we do with it? And this brings me to the last feature, which I'd like to show you, which is the ability to add React components directly to your application. So if you're wondering what React is, it's a JavaScript technology which I think was introduced by Facebook first, and it became wildly popular, both for building complete, complex web applications, reusable components, and libraries of reusable components. And we created Shiny React to make it possible to use those React components and React libraries in your application. But up to a point, it was designed rather to create packages which wrap other JavaScript libraries and not to create React components directly in your application. Rhino 1.4 brings the possibility of creating React components directly in your application. And let me show you how that works. So I won't be going into too much detail on the JavaScript part here. So don't worry about that if you are not into JavaScript. I just want to showcase what's possible. So I'm going to go to app.js directory and open this index.js file. Initially, it's empty. This is the place where we can write all our JavaScript code. First thing I want to do is import a useState function from React. As you can see, I do not need to do anything else about adding React to my project. The only thing I had to do was to install Shiny React dependency. Rhino is designed to automatically pick that up, and it is now available in my JavaScript sources. Now I can define my component. And components in React are simply functions. In this case, I'm creating a component called reveal. Its purpose will be to render its children in a div with a button, which can be used to either hide or show those children. And now I will skip over the details here, because this is not a React tutorial. I will just point out a couple of things here. So what you can see is that we have something that looks a bit like HTML here, but it's not HTML. It also has pieces of JavaScript. This syntax is called JSX, and this is what you typically use to define React components, and Rhino directly supports it. So you can see that our component is simply a div with a button inside. This button, when we click it, it will toggle its state between being visible and not visible. The button itself will either show text, hide, or show, depending on this state, and it will either render its children or not, also depending on this state. Simple as that. We won't be doing any more magic here. To use this component in Rhino, we need to register it. We do it with function register React components. And I simply need to pass this component which I just defined to this function. And this is it for the JavaScript part. However, similar to Sass, before I can actually use this component in my application, I will need to build this JavaScript to a minified and optimized file. Because browsers do not directly support this kind of syntax, this file needs to be built into something understandable by the browser. Again, we have an add-in for this, so I will need to build JavaScript. Similarly, I will say yes to automatic rebuilding whenever I introduce changes. And just like that, my JavaScript is built. So I can now use it in my R code. So to do that, I will go back to my docs module. And to make use of the reveal component, I will need to take one function from Rhino, which is called React component. And it will allow me to declare this component in our code. This simply means creating a function an R function which can be used to put that component into your UI. Just like Bootstrap page is a function which you can use in your UI. So basically, we need to call the React component function with the name of the component, the same one that we passed here when registering the component. With this, we can now use the component in our UI. So I'm going to grab my whole UI in this component. I will now save my module. And let's rerun the application. And you can see that we can no longer see the message in the center, but instead we have a button, maybe not beautifully placed, but this is what we had in our code. We can now click show, and this will show us the message. We can also hide it. And by the way, this is all happening in the browser without any server browser interaction, which means it's very fast. You don't need to have connection with the underlying server for this to work. And this is it for the presentation, and this covers all the features which I wanted to show you. So it's now time to chat if you have any questions. So I see there are some questions in the chat, but as I was presenting, I was not tracking it. Okay, so I will try to read the questions from the top and answer them one by one. Okay, I will read the question from Justice Clutter. I would be interested in your opinion on which UI framework one should use to have a future-proof, as best as can be, project. The Rhinoverse has 3 UI frontends: Fluent, Semantic, and Blueprint. Never heard of that UI. Your tutorial is focused on Fluent. Semantic seems slightly dead, and it's not clear if the Semantic UI will catch. Blueprint, I have never heard of. All right, so let me maybe clarify that it's not really the packages that you are mentioning here, like Shiny Fluent, Shiny Semantic, are part of Rhinoverse, but it's not really, they are not really the front ends available to you when you build a Rhino application. You are free to use any other R package. You are not limited to using packages in Rhinoverse. I just want to make that clear that these are the packages that we created, and our focus for now and for the future is to make sure that they work well with Rhino. But it's not the only options. You are free to choose from any of the other packages which you would use if you were creating a Shiny application without Rhino. Now, in my opinion, which you should use to create a future-proof UI or future-proof application, well, I think I could recommend to use whatever best suits your needs. If you find that some of the packages that we have in Rhinoverse suits your needs, that's great. You are certainly going to maintain them and expand them in the future. I would say that the choice is more about what kind of components and what kind of look and feel you require. For example, Shiny Fluent is based on Fluent UI, a library coming from Microsoft. So all its components meld very nicely with other UI elements of Windows operating systems and other Microsoft products. So if this is something that you need in your application, that's probably the package to use. However, if that's not what you need, then probably you should look for something else. And I guess the general advice for picking technologies to use applies, which means just check which packages are popular, seem to be well maintained, and yeah, this is the advice I would give. So I hope this answers your question. I'm not sure if we can have people asking these questions chat here with us. Just Gigi?
I'm here. Hi. Okay. So there is a question. Okay, is there a function for adding a new module versus using a Shiny tool?
A function for adding a new model versus using a Shiny tool. To be honest, I'm not sure if I understand this question correctly. Oh, I see. I see. So unfortunately, the add-ins which I was presenting are just for RStudio. So Justice says that he's using VS Code, and at this point, we do not have any plugin for VS Code, which can do the same thing. By the way, in my work, I typically use VS Code as well. I'm using RStudio here because it's wildly popular in the R community, and that's why we focused on adding functionalities targeted at RStudio. And it's a good point that we could add functions to Rhino which are independent of the IDE that you are using. And to a large extent, this is the case, actually, because you are free to use the underlying functions for all those, pretty much all those add-ins besides the new module add-in. This is the only add-in which doesn't have a corresponding function in Rhino which can be used without RStudio. All the remaining functions can be used directly from the R console. So, for example, to build Sass, you have the Rhino build Sass function. To build JS, you have Rhino build JS. For linting R, you have lint R function. The names are pretty self-evident. I guess it's a good point that we could think of a function for creating new modules that could be called directly from R.
Okay, awesome. Thank you for responding, and I hope that answers the question. All right, so what is the push for a trailing comma? Same person.
A push for trailing comma. Yes. So I briefly mentioned it. This is a very small thing, but trailing commas make the list of import statements. Don't worry about that one. But I started, so I will still answer it. We have a couple of rules. Some are more important. Like we have four new rules in this release. Maybe in the future we'll have additional ones. Some are more important than the others. I'd say that trailing comma rule is not one of those very important. But well, basically, having each line end in a trailing comma means that when you are adding a new line at the end, you are only editing that new line, which makes it easier to review your code. This is a tiny difference, but it matters a little bit because it's also easy sometimes to forget that comma, especially if you are reordering lines. You want to order them alphabetically, which is the recommended practice, and for that you need to move the last line to the middle. You just cut and paste and it will work. You don't need to remove comma in one place and add it into the other. So really small thing. We thought that it makes your life slightly easier if you follow that rule, and that's why we added it.
All right. So we have a question from David. Nice feature to manage package dependencies. What about using packages which depends on reticulates and a Python virtual environment?
So honestly, I cannot say too much about this because Rhino just doesn't have any direct support for working with Python. It was never, or maybe I did not meet that need in the projects which I saw. If we had Python somewhere, it likely was hidden by an API, which was then accessed from Shiny. And that's why this need never appeared, and that's why there is no direct support in Rhino for that. With that said, there is also no blockage to use it. Rhino is a framework, and it does force you or nudge you into some directions. It requires some specific structure of your application, but to a large extent, you are free to do with it whatever you want. In particular case of using Python, Rhino just doesn't have any direct support right now, which who knows, maybe will change in the future. But as I said, right now, I have never seen a need for that in the projects that we were creating.
All righty. So, does the Sass prebuilder work persistently in the VS Code environment?
So the Sass Rebuilder is independent of VS Code, I would say. Basically, if you want to use it in VS Code, you won't have the add-in which will launch it in a background job for you. You'll have to do this step of doing it in a background job yourself, which simply means creating a new R terminal and launching the function build Sass yourself, and it will keep rebuilding there. So it will work, but it does not have a support directly in VS Code. This is kind of more manual, but there is nothing stopping you from using it that way.
All right, moving on to the next question. So if we have an existing Rhino app built out quite extensively using the old add package to dependencies.r, I think you might need to read it, Kamil. This is like code in between.
All right. Yeah. I will read the question and then I will answer it. So if you have an existing Rhino app built out quite extensively using the old add package to dependencies R, add via rn, update rn_vlog, are there any ways you'd recommend transitioning to package install? Will it work seamlessly by using package install for all future package additions? So the quick answer is that absolutely it will work without any problems, because package install is just a convenience mechanism. You can still use rn functions directly. You can perform those 3 steps manually, and it will work as long as you just perform those steps manually. These 2 ways are coexisting. Package install, package remove are just for your convenience so that you can do it in a single step. There are some situations where you might need some advanced access to rn machinery, and you're totally free to do that. You can at any point use rn functions to do something more advanced. You can change its settings. It has some caveats, of course. You need to know what you are doing. Rhino won't support you directly in that, but as long as you are working with rn and you know what you're doing, you'll be fine.
All right. I don't think we have any other questions, and hopefully I'm not skipping anything. So how about we wrap up?
Yeah, I think we could wrap up. So on my side, thank you so much for joining. Thanks for listening, and thank you for questions. It was a pleasure to present. I hope you join future sessions as well.
All right. Thank you so much, Kamil. Thank you so much, everyone, for joining the session. We hope that we see you in the next training gathering. It promises to be exciting. And also, we hope you register for TinyConf. The link is in the chat. Register. Early bird is still open. And please join our Slack community, Tiny for All. And also, there's also a list of articles about Rhino that we hope you will find useful. So thank you very much, and enjoy the rest of the day. Bye.
Bye-bye. Thanks.